committee process. Our faculty advisor is Dr. Some of the issues we're trying to address with our project is the high demand for green energy. There's a growing demand worldwide. There are many development areas that don't have access to centralized power grids due to the small villages having low populations and being too far apart for a centralized power grid to be efficient. And the biggest concern is that power generation is the single largest source of US global warming in emissions in the United States, hopefully to have a grain of sand and help out with that. The main objectives of the project is to provide a clean source of energy with absolutely zero emissions. More specifically, to develop a parabolic collector that will produce enough thermal power to run a steam engine and having a steady flow of steam going through the engine. Being able to build this small prototype engine to run on relatively low pressures of around 10 to 25 psi of steam, and to hopefully close the system with a condenser to be able to recycle the exhaust steam from the engine. Motivation behind the project is to help with the small power needs of about 750,000 Americans living off the grid as of today, to renew interest in steam power generation since the discovery of fossil fuels decades ago that overshadowed any interest in alternative fuels, and help lower carbon footprints of humanity as a whole, at least on a small scale. The major components of the project is the solar collector. After looking into several solar reflectors, we decided that this was the best option to be able to harvest the sun's rays in any angle of the day and have a large surface area exposed to the heat and be able to take advantage of that. There are we narrowed down it to several steam engines that we use to have, like I said, to be able to run low pressure of steam. A water pump to be able to pump the water into the system, and a condenser to hopefully be able to recycle the exhaust steam. And I'm going to probably Alejandro to talk about the engine alternatives.
Okay, so after doing the research, we have narrowed it down to these two engines. First off, the Green Steam engine was designed by Robert Green, a mechanical engineer, a few years ago. The advantage of this engine is that it runs on very low steam pressure and low volume. It can freewheel as low as 2 psi. It can also run in any position, so we also took that into consideration. Now, the bad thing about it is that there's very few design specifications. So if we do decide to build this one, we will have to modify it and do alterations in order for it to work as we want it to work. The second engine that we're looking into is we can also convert a weed eater gasoline engine to run on steam. That has been done multiple times. There's a lot of do-it-yourself tutorials online, so we do have a guide as to which way we want to go. There's also very expensive materials. The only bad thing about that is the timing and the lubrication. That's something we have to look into ourselves and adjust as we go by. Now, for the design considerations, we wanted to focus on the solar collector since that's going to determine how much power we're going to be able to get out of the system. So we wanted to focus the solar collector on the ideal surface area in order to maximize the absorption of the sun's radiation. That's the reason why we chose this design instead of any other. Material-wise, we had to go with copper since it has the highest thermal conductivity of any available material, and at least regarding the price that we want to stay within budget. And then the diameter of the tubing, if we wanted to make it ideal for the volumetric flow rate, we don't want to go too big or too small. Now, we do have an alternative design in case we do not get the pressure that we want out of the system. We can also supplement it with a solar reflector, putting our system in the middle and then enhancing the thermal energy for the steam production. Now, the circular reflector that we looked into, the reflectivity is up to 97%, so that's going to enhance the thermal energy greatly. These are some of the most designed, some of the basic parts. We can have the intake and the exit valves, the copper tubing, the copper wall, and a plastic cover that we're going to try to generate a greenhouse effect in order to keep the system at a certain temperature. I'm going to hand it over to Charles and go into the challenging aspect.
In the process of our project organization, we came up with a series of challenges aspect that we thought that gonna come and might arise in the future. The first one is the bonding copper plates for the solar thermal collector, the molding of the copper parts into an optimal parabolic shape, finding the ideal flow rate to generate the steady steam pressure, and calculate the required tube spacing in order to generate the necessary steam to run the engine, and find the best diameter of tubes. For the cost analysis, we did some research, and we estimate the price of our two main components, which is gonna be the solar thermal collector and the steam engine. The solar thermal collector came out around $320, and for the steam engine, the one Alejandro talked about, which is the rubber green one, is around $250. This leaves us to a cost of $570. For the timeline, we did the timeline for the remaining of the year, and we're still working on the project design, and of course the cost analysis is gonna slightly increase as we go further in the project. We also have to do some simulations. We've already done with the research survey, some project formulation out of it, and we think that the part that's gonna take us most time is gonna be the construction part and testing, which are very important. We chose this project because there's high demand for green energy, and it's environmentally friendly. We wanna thank Dr. Trematic for the support. This concludes our presentation. Thank you.
Sure, okay. Again, a lot of the same questions as the last group. So what actually are you guys doing? It's very tough to
We're
see.
gonna be building the
Yeah.
actual solar collector
Okay.
to generate steam, and then
Right.
depending on how much steam we're able to generate, we're gonna select one of the two engines that we showed
Okay.
and try to generate mechanical rotational power, and then with that, you can pretty much run
So
what.
what's the switch between the two? What's the criterion that says pick A or pick B?
Well, if we are able to build a system that generates the 20 PSI, for example, we'll go with the green engine, with the green steam engine, because that one is more efficient since it was designed by an engineer, and we just have to build it and make sure it just adjust it to run, to optimize it so it runs to our desired needs.
Okay, you said it. You might have said that. I don't
Okay,
remember exactly. It's definitely worth a flow chart or something saying, this is the first step. We're gonna, because you said you were doing prototype design, I guess, September, October, or something
Well,
like that,
we're
right?
planning on starting as early
You
as
should
possible,
Definitely,
but.
definitely, yeah. So put that in the table way back.
Oh, okay.
Start now, to be honest with you. Your components are pretty simple. You can go to Home Depot for $300. Start now, you know? Put it together and see, and then it'll tell you which engine to get.
Yeah, we're just trying to figure out the maximum surface area that we're gonna need in order to
Right.
be able to make sure that we're gonna generate, worst
Right.
comes to worst, we'll be just heating water, we're not gonna be able to generate steam.
Yeah, exactly.
We'll make it better design.
So, yeah, definitely talk a little bit more about kind of the math behind
The
it.
heat transfer.
Yeah, exactly. Okay. Some other stuff now, right?
I wrote ideal size question.
Okay, go back a couple that I remember. There, so ideal surface area to maximize absorption of sun's radiation. It would be worth just citing where you got that and stating why you think that that's the ideal size, you know? I mean, I get it, looking at the sun, okay, there's.
Yeah, exactly,
Right.
we'll always have the same surface
Right.
as opposed to the sun, no matter where it is.
But it's worth stating, hey, we did the research and this is what we got. Because, unless you specifically came up with the idea.
No, we're
Okay.
not.
Yeah.
As a matter of fact, as a general rule, you want to make sure you're very careful about citations.
Yeah,
the
right.
references.
And things like, so, you know, throughout, some of the images, you know, I know you guys have images from the internet or whatever. It's a fine line when you start putting in images that other people make into your presentations, so just be very careful.
On the actual report, we did list all the references.
Right,
On the actual
okay.
report, but on the presentation. we
It's
just
worth
didn't
put a
have-
little thing on the bottom, even if we can't read it, just put a little thing that's there that says,
Where
hey,
we got it
look,
from.
yeah, we got it from here.
Dr. Tony?
No, that's it. I guess my last question is, are you all, and this applies to all the groups, have you all been exposed to the evaluation rubric that was evaluated on by the IAB? So you're aware of all of the line items and all of that?
Well, you mean, there's an outline to the report to which?
No, this is the evaluation rubric that the evaluators, the judges, the IAB will be using to assess you.
It should be on the website?
On the
Well,
website.
your professor will
Yeah.
send it to you, make sure you have a good look
I
at that.
don't know.
And definitely tailor your presentation to that, because it's very hard for us when we're going through.
Yeah, that's one of the
It's
difficulties we
very
had, we
difficult.
just looked at other
Right.
examples to best guide us.
No, yeah, that's great. So just take a look, because if you can do it in the right order too, then we, oh, fine. You know, it's just so easy, right? Versus, oh, wait, now I'm down here, oh, now I'm up here. You know, then it becomes hard. So, yeah.
But it's on the website since the beginning of the semester. I
Sure,
showed
yeah.
them in
That's great.
No, yeah, I know, it's very tough.
Just
Yeah,
there's a lot of reminder.
Yes, thank
That's
you.
fine, yeah.
And I'm doing the same thing with 4905, just in case, for the next group.
Okay, thank you very
That's
much.
what we do.